So today let's start with a simple problem. We have to just find the mean and median of the array. So mean is just the average of all the numbers present in the array. For adding the sum, we will use the inbuilt function of STL. And for median is a middle number in the sorted array. So the array is not sorted given to us. So first of all, we will sort the array. And we will be returning the middle number. So middle number will be n by 2. So for example, if the average of the two middle numbers, okay, they have told the median is the average of the two middle numbers. The number of elements can be odd or even. Okay, 5 is the median for even numbers. Okay. So if n modulus 2 equal to 0, that means even number are present. For example, 4 numbers are present, 0, 1, 2 and 3 indexing will be there. So 1 and 2 numbers indexing at 1 and 2 will be added. And if the number of elements are odd, just return, for example, elements are 5, n by 2 is 2. Okay. Submit this. Okay, it's running fine now. So let's move to another problem. So this problem says you have to find all the number of ones present in the array. And the tricky thing is that the array is sorted in a non-increasing order, and only 0 and 1 are present in the array. So that means the one will be, if the one will be present in the array, it will be from the starting position till the occurrence of the first 0 in the array. So the first approach is the iterative approach. We can find the index till the 1 is present and return the count. Second is we can reverse the array and find the first position of occurrence of the 1. And the position of the first occurrence of the 1, we can subtract the total array size from the first index. That will give us the total number of ones present in the array. So in this approach, we will be sort the array. That will also like this is like sorting the array, like reversing the array. Reversing the array will also take the order of n time. So that will also not be a better approach. So better approach will be using the binary search approach. Binary search in this, let me tell you, we will firstly low will be equal to 0 and high will be equal to array dot size. Each time we will going to the middle element and we are checking if that element is equal to 1 or not. If that element is equal to 1, that means we have to move to the right side because more 1 could be present. If that particular element is equal to 0, that means we have to move to the left side because ones are not present up to that index. So using this approach, let's move further. Let's find out the middle element. So if array of mid equal to 1, that means our answer could be possible equal to mid because that would be the last one. So and we will move to right side, mid plus 1. Else part, else we can't say our answer could be that element. We will just move right equal to mid minus 1, high equal to mid minus 1. And we will return our answer. So answer will be mid. Mid, that means mid plus 1. We have to return mid plus 1. Okay. For example, there might be no 1 present in the array. Let the declared answer equal to minus 1. Let declare answer, okay. If answer equal to minus 1, return 0. Because there is no 1 present in the array. The array is itself starting from the 0 only. Else return answer plus 1. Let's check this code. Okay, it's running fine. So the time complexity will be equal to order of log n, and no space is used by us. Okay, let's move to another question. So this question is days before n days. You are given two integers d and n, where d is the day. Out of the 7 days of the week, d varies from 0 to 6. Okay, Sunday to Saturday. Okay, you have to return the index of for the day for which is n days before the given day d. Okay. So they are saying there the D will be given. So what is the D range? D range is not, D range is not given. Okay. So nothing like, for example, D is equal to 4. So D minus 3 is equal to 1. So what is 1? So 3 days before the 4 days is equal to first day. Similarly, what is the 2 days? 2 days minus 19. 2 minus 19 will be equal to minus of 17. So minus of 17 will be taken as modulus. We will take the mod. Minus of 17, I think we will be continue adding 7. Like minus of 17 plus 21 is equal to 4. Okay, I can understood what the question is saying. So our basic approach is equal to, we have to subtract, we have to say d minus n, and after that we have to keep on adding the 7 into it until that number become positive. So the approach to this question is in actually in this question we have to return d minus n modulus 7. But d minus n could be negative, like in this case d is equal to 2 and n is equal to 19. N minus 2 minus 7, 19 is equal to minus 17. And we have to return the positive answer. So what we can do is, first of all, we will take the modulus of d. D is equal to d modulus 7. Or we can leave for the d. There is nothing need. Let take it for just for the n. N is equal to n modulus 7. Now we will return d minus n plus 7 modulus 7. Why plus 7? Because our answer might be still negative. D minus n still be negative. So we will add plus 7, and after that we will be doing the modulus of 7. Let's check this out. It's running, only 4 test cases were there. So this was simple question, nothing to. Let's move on to the next question. This question seems to be quite easy. In this, we have to find the first digit of a number. Like n is equal to 123, the output is 1. For 9768, the output is 9. And the range of the number is 10 to power 9. So there are at most like, you can say 10 digits in the number. So while n is greater than equal to 9, I think we can keep on dividing the number by 10. After the first digit number will be remain with us. Like for n is greater than equal to 9, while n is greater than equal to 9, n is equal to n divided by 10. Because only the first digit number will be remain with us after the return n. Let's submit. Okay. Okay, 9 is greater. Oh, n is greater than equal to 9. Sorry, I read while n is greater than equal to 10. 7 test cases are given. Okay, let's move on to the next question. So this question is also solved by 41,000 persons. So given a number represents the number of apples in the bag. For example, there are 9 apples in the bag, and me and my friend are playing a game. Both of you pick one apple turnwise from the bag. It is given that you tempt the first. The person last picking the apple will be a winner. Just a simple question. It is nothing in this question. If it is will be odd number, the apples will be odd. I will be winner. Otherwise, my friend will be winner. If n modulus 2 equal to 1, I will just return me or you. Else I will return my friend. फ्रेंड एप्पल डिजर्व तो नहीं करता, चलो ठीक है, देना पड़ेगा. तो सभी कॉलम इसमें से. Next question we will try some hard question like little. So let's try this problem. This is the problem of the day even. We are given two strings. We have to check that S1 is a subsequence of S2 or not. A subsequence is like a continuous sequence pattern, but the in between the characters can be skipped. Like in S2, the subsequence could be AXP is one of the subsequence, YDXP is one of the subsequence. So we have to check if S1 is a subsequence of S2 or not. Like in this case, AXY is not a subsequence. For second input, GK, GKS, REK, G then K then S, REK is a subsequence. Okay. So I think this question is also not so difficult, because what we are going to do is we will take 2 pointers, let's say I and j, on the ith 0th index of both the strings. If there will be match, we will move S2 as well as S1, and if there will not a match, we will move S2, because S1 character has to be matched to the S2 character in the string. So let me explain more by coding. Letting the n is a S1 dot size is equal to S2 dot size int I equal to 0, j equal to 0, while I less than n and j less than m. Suppose what if the S1 character is matched to the jth character of S2 string. So what we'll say, okay, then it's so good. We'll move I plus plus and j plus plus. What else? Else case ith character is not matched. For example, here is here is y. We have to move to the jth character of second string. And after that, if I equal to n, we will return true. We will return true, yeah. Else that means we can't find the subsequence of that string. We have to return false. Let's submit this code. Yeah, it's running. We even on one geek point. Geek bit. Okay. Let's solve next problem. So this problem is LCS of 3 strings. You might remember there is a famous question of LCS of 2 strings, in which you have to find the longest common sequence among the 2 strings. So that is a famous DP problem. In that problem, we usually check if 2 strings, the indexes of both the strings are equal. We increment the pointers of both the strings. Else, Else we increment either the first part of the first string or the another index of the second string. So similar approach will be followed in this question. In this question, the question is asking the LCS of the three strings. Similarly, so I think this is also DP question. What will the approach in this question is that we will taking the three indexes I, J, and K. So if I, J, and K, if all the three indexes of all the three strings are equal, we will move the pointers of I, J, and K at one time at the same time. What if I is equal to if I is equal to the s1 dot size, or j equal to s2 dot size, or s3 equal to k equal to s3 dot size, we will return 0 because the string is because there is no more string left, so we have to return 0. Else, if the strings indexes are not equal, we will find the maximum among the three cases. In first case, we will incrementing the I pointer. In second case, we will incrementing only J pointer. And third case, we will incrementing only K pointer. Among them, we will returning the maximum length. So let me tell you the approach for this question. Let's take the lengths. Suppose S1 is equal to length of S1 to S. Let ABC be the size of the strings. S1 dot size. C is equal to S3 dot size. We will be solving this question using recursion and DP, recursion and memorization. So let's first write only the basic recursion code. After that, we will memorize that code. Return function. We pass the strings A, B, C lengths S1, S2, S3. We will also passing the indexes. Okay, now let's code. Int fun, int A, int B, int C, and the strings. Let's copy the strings from here only. Okay, so now goal set. Int I, int j, and int k. These are respective indexes for all the three strings. So we start with the base case. The base case will be if I equal to A. A is the maximum length of the string. We have to return 0. Similarly, if j equal to B, or k equal to C, we have to return 0. And other case is if S1 of I equal to S2 of j equal to S3 of k. What will we return? We will return 1 plus fun A, B, C, S1, S2, S3, I plus 1, j plus 1, and k plus 1. We will move all the three indexes parallelly. Else we will returning maximum. Maximum what? Maximum of fun, A, B, C, S1, S2, S3, I plus 1. We will move the ith index. We will move the ith index of the S1 string and kept J and K as constant at same indexes, I mean. And among the remaining two, actually we have to return the maximum of among all these three. And maximum of this. Okay. Similarly, A, B, C, S1, S2, S3, I, J plus 1, K. And over here, A, B, C, S1, S2, S3, I, J, K plus 1. Okay. So this is a basic recursion. Let's check this out. Is it running fine or not? TLE, time limit exceeded. Okay, let's try to optimize it. A TLB will come, and what parameters are changing? In this, we can see that S1, S2, S3 are constant. Only I, J, and K indexes are changing. What is the size of the I, J, and K? These are nothing but the sizes of the strings. So we have to take the 3D DP. 3D DP in this we have to take a vector, vector, vector int. Okay, DP. And first size will be a plus 1 vector of vector int b plus 1 vector of int c plus 1 comma minus 1. Hopefully now we have to pass the dp also. Okay, this we will add if dp of I, j, and k not equal to minus 1, we will simply return dp of I, j, and k. And here also while returning we will store dp of I, j, and k equal to this. So now let's try and run this question. Okay, this is some. Okay, DP is not mentioned over here. DP will come here also, here also, here also. Okay, it failed for the one of the 9 test case where it is saying your code output is 0 and the output is 1. And the one, the character which is longer or common in Trie is so there is one character in common. I can't find any called DM8J. 8 is not present in the first. D is not present in the first. M is not present in the first one. J. Okay, J is present in all the strings. That's why the answer is 1. So where might we had gone wrong? Let's check the code again. Okay, it's running fine. What actually before that we have added equal to this over here. I just added and s2 equal to s3 of k. This minor change I have done, and see this is running now. So let's move to the next question now. Okay, let's do this question. In this question, we have to find the last digit of a power b for the large numbers. So, like in this question, they have given that 3 power 10. 3 power 10 is equal to this number, and the last digit is equal to 9. This is actually related to mathematics. If you will know that the pattern repeats itself for all the, so what could be the a could be any number, like a could be from range from 1 to 1000 and b could also range from 1 to 1000, but in a the last digit could range from 0 to 9 only, and in b could range from 1 to 1000 could be any number. You will see that from 0 to 9 all the numbers follow some pattern in their powers. For example, in case of 6, you 6 power anything will the last digit will occur also as 6 only. For example, similarly the case of 5, 5 the power of 5 say 2 3, and the ending digit will always occur as 5. Similarly, like the case of 2, 2 will have the pattern of 2, then 4, then 8, then 6, then again repeat to 2. So similarly, what we could do is, in this case, we will find the last digit of the eighth string A. We find the last digit of the string A. For example, this is in 3 only, and the B power. B power for there will be cases. Now there will be multiple cases for each of the digit. Like for example, if it is a 1, or for example, it is a 1, we will return 1 only. If it is a 2, then we will take the modulus of B by 4. b by 4. If b is equal to 0, then we will return 1. If b equal to 1, then 2. If 2, then 4. If 3, then 8. If 4, then 6. Like similar pattern will go on. Like in this question, nothing but the if else cases will be constructed. For example, in case of 7, we'll see the pattern is followed as 7, then 9. Because 7 7 49, 9, 9 into 7 63, 9 7 3, and then 1, and again 7, 7 9 6, 7 9 3 1, and again 7. So I think we can better do if you copy these cases rather than writing all these cases in if and else. Let's check if someone has written these all these cases, because it is not if we go on doing the a power b, that's not a feasible solution. A power b could be a huge number. Let's say the editorial solution of this. Yeah, see this. Even they have told that like this last digit of power of 1 is always 1. In case of 2, it is 4 8 6 2. In 3 also 9 7 1 3. Similarly, I told about 5 and 6, it is same as 5 and 6. So these are the cases, but nothing that we have to write in this. So see the editorial solution. What the hint they have given? Similar type of hint. Yeah, cycles of 2 and 4 only. See, they have also find the last digit. If it is 0, then returning 1. Uh, they have nothing. They have found the cases only. This is done by something else approach, I think. Sure. But the best in this case would be go through the cases. Nothing you will have to. Okay, let's submit this and we'll move to the next question. If in submissions, let me check if they have done through the cases approach. Wait, just wait. Okay, let's try this question. In this question, we have to delete the minimum characters so that resulting string is a palindrome. This is also a DP question. So what the approach in this question will be? Basically, we will be having two pointers. The first will be having at 0th index, last at the n minus 1th index. So if both the characters are equal, we will incrementing the first pointer and decrementing the last pointer. If both the characters are not equal, there will be two cases. One, we have to remove the ith index character, or there is second possibility we have to remove the last index character. So based on the basis of two, we will once we will remove the ith index character, and second time we will remove the jth character index or jth index character, and the end we will return the minimum number of deletions required in each of the case. We will return the minimum number of deletions. So we will solving this question again by uh, recursion plus memorization. So let's first write the recursion code only. That n is equal to s dot size. So return one of s n 0 last index, 0 be the first index, n minus 1 be the last index, and what else? No file. Let's check it. In fun string s int I int j. What will be the base case? Base case will be I equal to j. if I is equal to j or I less than j, if I less than equal to j, so what will in this case, sorry, I greater than equal to j. If I is greater than equal to j, we will simply return 0, nothing. Else why, what we will return? If s of I equal to s of j, in this case also, what we will return? We have to return nothing. We will say return fun of s I plus 1 and decrement the pointer j minus 1. Else case, else there will be two possibilities. We will return minimum of fun s. One time we will be incrementing the ith character. That means we have deleted the character at ith index and kept the character at the jth index. Second time I am deleting the character at jth index, so j minus 1. Okay. So plus 1 will be there. Plus 1 because we have removed actually one character. So let's check, is it running? Obviously TLE will occur because so what are changing? I and J and changing. So there will be a 2D DP. Okay, there is saying then minimum 34. 34. Okay. Right. It is a 2D DP of size n plus 1 vector of int n plus 1 again minus 1. DP. Yeah, TLE, that means our approach is fine. By using the memorization, our code will look okay. Actually, the reason for using the memorization is because there are some cases that overlap. The main approach is just for the recursion only. If you can think of the recursion code, there is nothing left in the code. Memorization is too easy process. If dp of ij not equal to -1, not equal to -1, return dp of ij. So here also we will say return dp of I and j. Let price over here also. Now let's submit. Oh, db is not passed over here. It will give error. Yeah, it's running fine now. So let's move to the next question. So let's try this question. This seems to be a good question. So in this question, we are given an array of string words. For example, we are given in this array of words pro, prob, problem, pros, process, and processor. Among these words, we have to find the longest word such that every prefix of that word must be present in the array words. For example, pro is a word. Pro, the prefixes of pro will be p, pr, and pro. These are all present in the array words. But there is also this word pros. P, pr, pro, and pros is also present in the array of words. If multiple strings are present, we have to find the maximum length string. And if maximum length is also, there are multiple strings like PRO's C is there, like PRO C, there might be string. So we will be giving the lexicographically smallest string. as our answer. So what will be the approach to this question? We have to find the string for which all the prefixes of that string are present in the words array, and that string should have the maximum length. So the I think this question could be related to the trie question, trie data structure. Actually, if some this sort of data is given, a large number of words are given, and some we have to find some word is present or not, or we have to find the similar word or a palindrome of that word. The trie data structure should come definitely come to our mind. In trie data structure, what how trie could help us in this question? Uh, Suppose if we store all the words of our words array in the trie data structure, after that we can move iteratively from each index of the trie node and check if that like it will be continuously one. The bool of that word will be continuously one while moving while we will be moving down to the trie node of a tree. Like p will be stored, and its bool word be equal to one. Pr will be stored. Pro will be stored. There might be one word PRB. For example, PRB is also stored. PROBL is stored, then PROS is stored. But will our answer PRB will our answer? No, PRB is not will be not be our answer, because pros is the longest string. We have to find the longest string also. Uh, once all the words are stored in the trie data structure, we can simply move from iteratively from one index to uh, iteratively from that node to the another node, and checking and check if the if that bool of that word is one, that means that word is actually present in our words array. We can continue moving downwards, otherwise we have to return. Yeah, this I think try would be best for this question, and the time complexity will be also be uh, I think try if this question could be solved using try, then we are not worried about the time complexity. So let's first make the try orders for the class. Bool is word. Bool is word will tell that for example, there might be a word like PRO. PR, when while we are storing this word PRO, P will be stored, R will be stored, then O will be stored. The only O index will take the bool is word as one, because P and R are not present in one words. For example, when saying this is the basic structure of the trinode. If you have not worked with trinode before, I think this question is not for you. Then you must go first for know about the basic data structure of the trie. I will try to explain how much I could. So let it 10 equal to words dot size. Now we will storing for each word in our trie node. Okay. So So insert function will be used to insert all the words in the trie data structure. Void insert. Let we have declared the root trie node. Trie nodes are root, and this is the string word. So okay. So let's find the first character. What is the present in zero character? Word of 0 minus of a. So there will be two cases. If root of children of ch, here will be int, not character, because we have from 0 to 25 it will map is equal to null. We'll say root of children is equal to new trie node. Okay. No trie node else we'll say not else, so we'll say insert return. We just pass insert root of children of ch. After that, word dot sub str1. That means we will be removing the first character of the word that is already we have pushed into the trie node. And here the base case will be this. Actually, I'm inserting using the recursion. If a word dot size equal to 0, we will say actually each time when I'm inserting the character in that trie node, I am removing the first character of that word. And once the word size will become 0, we'll say true root of is word equal to true. Nothing. And here I will return. From that point, we will be returning from the. So it seems like it's okay. Insert function is okay. Root is word equal to true. Return case a word of 0 minus a. Fine. All the words are in the smaller alphabets. So the main for code will start now. Find the string, the answer string. Okay. So again the recursion, we will using the recursion. So like in second test case, you also see we will be inserting AB, we will inserting A, then ABC and ABD. So what there are two possibilities. ABC could also be our answer because A is present, AB is present. ABD also A is present, AB is present. But we have to return the lexicographically smallest. So ABC is smallest. So now what we have to return the string, not even length. That we also have to keep in mind. Let string answer equal to null. Let declare string answer. We are returning the answer, and here let's function. We will pass our string. We will pass our root of the trie node. Else what we will pass? Else I think nothing to be passed. So let's see if we could build this function. Hopefully we will. String answer. Okay. Trie node star root. Okay. So now I will iteratively I will move from root ABC. Okay. For int I equal to 0, I less than 26, I plus plus. Let me code first. I will tell the approach how I am proceeding. If root of children, I, that means I am checking if children of I is there any is that not null or is something is there. If this that is not null, and that must be true. That means that word is that it should be containing that word particular. And bool and is word. Okay. Root of children of I. That means that is now, for example, that is A. For example, 0. Root of children 0. That is something word. There is something word that we will be initiating, and we will checking if that is true. Root of children of I dot is word dot is word equal to true. This both conditions will be meeting. After that, we will proceeding further. I will be saying, okay. There will be cases like a E is A, N, A, and B, C is balanced, and B, C is like a B. B is B, B is B. Let's take two strings. One will be answer and second will be temp string. Okay. The temp will be another string. String temp. Because we have to maintain the string side by side. If and its length will be maximum, then we will store it in the answer string. The number two must be like a B, C, D is present. After that, okay, if the length exceeds, then I will be okay. If otherwise, I will not. Yeah, we are going the right path only. So now I will use a recursion. I will say fun. Hmm, should I temp? Yeah, temp equal to temp plus firstly character. Let's introduce character. Character ch is equal to uh, a plus I. A plus I am character. Temp plus equal to ch. Okay, fine. Temp equal to ch. Answer root of children of I. I will move in the root of children of I, and I will move in the temp further. Okay. Hopefully, this is a recursion I am calling. After all the recursion for the A is completed, I will checking if answer dot size is less than temp dot size. I will say update our answer. Answer is equal to temp, and hopefully this is the overall code. I think. Let's check the compile and run is giving some error or not. Might we will get some error. It will not be running the first attempt only. Okay, try mode. Try mode 6th line. Do we have okay, try node. Nothing output of working case across. So what is happening? Let me check. Okay. First of all, what we have done is we have iterative the code from 0 to 26. We have checked if root of 0 is equal to push the ch and temp is equal to temp plus ch. Okay. Let's see how temp over is. It is something adding to it or not. Make sure. After that, we are passing that root of children of I to the temp. Take it, then it's okay. Actually, temp is not print in something over here. Let's check if this is going inside. This is also not. Approach is this only. There is something like error in our code. Approach is will be this only. See out I. There is no output of the I even. Root of children of I. Inside should be true. Word is or yeah, this is the error I've done. Words of I only over here. Let's compile it over here. Okay, something printed finally. Okay, let's temp. Let's print temp only. Okay, let's see what is the output they are printing. We print end of answer. End of answer. Why? Because we want answer to be stored in this answer variable. So it is storing ABCD. So something we got. Why ABCD? Why ABCD? Oh man. Fruit of children of I. So we made some changes in our code. Earlier, the answer dot size is less than temp dot size was written downwards over here. I brought it up, and before moving to the next iteration, I have popped the temp last element from the temp. So let's run it the code and check if it is running or not. Hopefully, it should. Oh, finally it run. It is run. So let me tell you how this fun function is written. So actually, we have to find whether this that words are present in the prefix word or not. So what I'm doing is actually I'm checking for all the 26 letters of the trie node. Firstly, I'm going for the A node. I'm checking if A is present, then I will go from 26 letter of the further A from A to Z. If again A is present, for example AA, then again I am checking for the 26. Each time I am adding that character to the temp and answer. If answer dot size is less than temp dot size, I am updating my answer variable, global variable answer. So after that, if we returning from the previous callback, after that we have to remove that character, last character from the temp variable. So there I have pop back that last character from the temp. So this was all the code, and finally it is also running. We can also check the editorial solution of this, whether it is also same or they have done something else. The basic idea is that if we could hit that this is to be done by the trie data structure, then let's topic tags also. Topic tags is trie d strings BFS data structures algorithm advanced data structure. An editorial approach. See, naive Bayes is just like sorting and binary search, and the expected approach they have used also trie based prefix validation. So the main logic of this is this, if we give given a lot of strings now, and the code is also to output some string, something like that. Always think about the trie data structure. I think video is too lengthy already. We have 1 hour, so it's enough for today. We will continuing on this channel. Similar content will be posted, and hopefully you like this video. Please make sure to subscribe and share with your friends. So thank you.